Let's review ionic formulas. So it's important to remember that on the left side of your chart you have metals, and on the right side of your chart you have nonmetals. And to remember that the ionic charges go from +1 to +2, +3, +4, -3, -2, -1, and 0. Some you need to have memorized are aluminum with a +3 charge, zinc with a +2 charge, cadmium with a +2 charge, and silver with a +1 charge. Now, to swap and drop these and write the correct formula, we're going to start out with magnesium and oxygen. Now we see that magnesium's ionic charge is a +2, and oxygen's ionic charge is a -2. So we're going to swap and drop the charges so that we have magnesium 2O2. Now here we can see that these charges cancel each other out, so we can simply write magnesium oxide. Now we have chlorine and calcium. Now, the charge on chlorine we see is -1. The charge on calcium is +2. Now we should remember that we always have to write our cation first. So when we are writing the equation, we need to write calcium, then chlorine, and we swap and drop the charges. So we have Ca and Cl2. Now we have lithium and nitrogen. The charge on lithium is a +1. The charge on nitrogen is a -3. So we're going to swap and drop these charges. So the final formula will be Li3N. Now we have fluorine and potassium. The charge on fluorine is a -1. The charge on potassium is a +1. Now I see that my cation has to go first, so I write potassium fluoride. And when I swap and drop these charges, they cancel out. So all I need is K and F. Now I have aluminum and sulfur. The charge on aluminum is +3, one of the ones we need to have memorized. The charge on sulfur is -2. So I'm going to swap and drop these charges. So now I have aluminum 2 sulfate 3, Al2S3. Now I have aluminum hydroxide. The charge on aluminum is +3, and the charge on hydroxide, one of our polyatomics, is -1. So I need to swap and drop these charges. When writing polyatomics, it's important to remember to put a parenthesis around the polyatomic when assigning it a new charge. So I have aluminum trihydroxide. Now I have magnesium and acetate. The charge on magnesium is positive 2. And I see that from my ionic charge. The charge on acetate is negative 1. And I can find that from my polyatomics chart. So I'm going to again swap and drop these charges. Remembering whenever I write my new formula to put my polyatomic in parentheses. And the new charge is a 2. Next we have lithium bicarbonate. Lithium and bicarbonate. The charge on lithium is a positive 1. The charge on bicarbonate is a negative 1. Since these charges will cancel each other out, I can write lithium and bicarbonate. If I want to separate my polyatomic, I can put a parentheses around it. But it's not necessary because this would just be a 1. Next, we have ammonium and carbonate. The charge on ammonium, per my polyatomics chart, is positive 1. The charge on bicarbonate is negative 2. So, I need to swap and drop these charges. So I'm left with ammonium with a 2 outside of its parentheses and a bicarbonate. Now, an important thing to remember whenever unswapping charges, such as nickel to nitrate, is that transition metals like this, you find the charge from unswapping the ionic compound. So my charge on nickel would be positive 2. So I have nickel 2 nitrate.